Hi, welcome back to my statistics class. So this chapter, we're talking about linear regression. So first of all, scatter plots. So what's scatter plot? Scatter plot is a plot that of a paired quantitative data with a horizontal x-axis and a vertical y-axis. The pattern of the plotted point is often helpful in determining whether there is a relationship between these two variables. So for example, create a scatter plot that will involve these two numbers of cracker chops per second paired with the temperature. Okay, so we can let the temperature on the x-axis. So this is going to be our x on x-axis, and then the chops per second, put it as our y-axis. Now we need to determine the range. So from the x-axis, we know that the temperature varies from 17 degree to approximately 19 degree. So now we need to determine, hey, which is starting from where. So maybe here can be this is 0. So this is the origin, always starting with 0. But since we don't have data before, like on the temperature, we don't have data from 0 to 17. So we can use the line of break and starting with 17, and then 74, 76, 78. No, I'm sorry. Should be 80, right? Oh my god, mistake. So we have 74 and 78, 82, and then 86, 90. It's at 2 grams, and then with a 94, okay, and then 98. Okay, so y-axis stands for the chops per second, the cracker chops per second. Again, so the range is from what? 14 to 20, right? So maybe we can start with the line of break, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now we label every point. So the first point is when the temperature is 89, the chops per second is 20. So we found 89. So here we have 80, right? Oh, I'm sorry, 89. It should be close to 19. So this is our 88. So 89 would be in between 88 and 19. And then we found 20, which is here. So the second one is 19,320. 19,320 would be in here. And then we have 81,17. So I'm going to pause the video and just label it, all of them. Okay, I already labeled all of the points on that scatter plot. So I really want to say sometimes I miss some data set, so I have to erase it and redo it again. So this is a good practice for it. When you label it, I think it's good that when you label some data, you just cross it so you will not forget or missing any ones. So every time when I label some dots on the plot, I will just cross it. Okay, so here is our scatter plots. So remember the x-axis stands for the temperature. And then the y-axis is the chops per second. So, okay, look at our first question. After we're done with the scatter plot, is an increased number of chops per second caused by an increase in temperature? So what's increase of the temperature? An increase the temperature, which is from the left to the right. That's increasing in temperature. From the bottom to the top, that's the increase of chops per second. Okay, so does it cause by anything? No. Remember that scatter plots never tells us the causation. They only tells us the correlation. So no. So this is really funny. You can look up online causation versus correlation. You will find a lot of interesting example. If we want to find out the causation, we need a controlled experience, which we talked about that at the really early of these classes. Okay, so what happened in general to the number of chirps per second as the temperature increases? So look, the temperature increases, that means the data from the left to the right. So what happens? So when temperature increases, which is our x, what happens to y? Y goes up, right? From the bottom to the top. So the chirps increases as the temperature increases from the chart. We can see the trend here, right? In general, we see a trend like this. Whenever the temperature goes to the right, that means it increases. So the chart per second goes up, that means it increases. Okay, so in the scatter plot, we have explanatory and the response variable. So the response variable is the dependent variable. Why? So in our example, which is our output, we can sometimes use it as an output. In this case, would be the chirps per second. And then explanatory variable is the independent variable, which is also our input. In our specific case, would be our temperature in Fahrenheit. So we think that changes in explanatory variable might explain the changes in response variable. So you need to be careful about that. Even if it appears that y can be predicted from x, it does not follow that x cause y. So I'm going to emphasize the theme of this clause again. Correlation doesn't mean causation. Okay, so let's take a look at the pattern. So there are four main features that we want to analyze when looking at the scatter plot. So linear, curve, and no pattern. So when it comes to a linear curve scatter plot, what does it look like? Just like in here, in general, you will see there's a trend, a straight line like that. You can summarize the data like that, such as something like these going up with a straight line. Sometimes they can going down. So curve, they could be sines or parabola, but you will see the data something look like. But you will see the curve, right? They may follow some patterns. And then no patterns. If there's no pattern, they will be scatter or grouping, like everywhere. So this is no pattern that you can find the trends. Okay, so when it comes to a linear scatter plot, they have three directions. One is positive, negative, and neither. So if it's positive, that means the data in general you will see it going up. What do you mean going up? that means as x increase, that means increasing. Increasing is from the left. When you look at the data, from the left to the right. What happened to y? From the left to the y horizontally, what changes in y? Y is from the bottom to the up. So which means y increase as x increase. So the negative is going to be something look like this. The scatter part, the chain is going down. What's going down means? So that means as our s increases, our y goes down. Okay, leader. So there's two types. Either it's going to look like a straight line. We call it zero slope, right? Or they don't have, neither means they neither have a positive or negative direction. They could be our known pattern example that you can find a straight line along with that. Okay, so strength. So how strong they are correlations. So that means how close the point are to the line. Okay, for example, these, they have a positive correlation. So this is the line. So if the point look like this, basically you can see them, hey, it's really close to the line. So we call it, this is a really strong correlation. So what is weak correlation? So weak correlation is if there's a point, there's a line here, let's use a negative one. Sometimes they can be negative, sometimes they can be positive. So weak correlation means, okay, the line is really spread out. It's really hard to find it along with the line. But with the computer help us, we still find that this is a linear and this is a line. But we call this is a really weak correlation. Okay, what is moderate? Moderate means in between. I'm going to use the negative as an example because we've been using positive a lot. So there's a line. If it's moderate, that means in general, most of the point you can still see, hey, it's on the line, close to the line, but some are really spread out. But in general, you can still find it. Okay, so what's outlier and the grouping? So outlier, so do you remember outlier? So when it comes to a standard normal distribution, not standard, just normal distribution. If it's 2 standard deviation away, we call it, that's outlier. And when it comes to a skewed distribution, if it's, do you remember the 5 numbers methods? If it's 1.5 interquartile miles away from the data, we call it outlier. So when it comes to here, if we see there's a line, most of the points are in the line, and there's one. It's really far away from the line. We call this one is outlier. But later I'm going to explain what would be the criteria to determine, hey, this is our outlier. Okay, and the last set is called grouping. So you may see them, hey, maybe they cluster into one point, and this is cluttered into another point. Maybe that's like when you're talking about survey, about how many hours do you spend on study. If you survey a first grade student and then you survey another 12th grade student, of course you're going to have 2 different group of data, because first grade student maybe they just spend like 20 minutes to study after school, but whereas 12th grade student, they may need to spend like 2 or 3 hours every day after school to study. Okay, so here are the scatter plots So next time we were going to talk about more about this.